In the last video, we talked about dynamically allocating integers and showed how that worked. Now we're going to talk about dynamically allocating arrays, and this is where like the bread and butter of pointers and all of that works, is doing the dynamic allocating of arrays. So let's go into CLion and start an example. So we're just gonna, I'm going to show you what you might think you might be able to do and show you why it doesn't work. So I'm just going to do an int size equals 5, and I'm going to create an array of that. So int, we're just going to create numbers of an array of size, and we're going to say we're not going to allocate it first. What we're going to do is we're going to create a couple functions. We're going to go to helper and create a function of void, and we're going to just initialize init array, and we're going to pass it in the int array and the size. And then we're also going to print one. So we're going to have a void print array. And we need the same variables, array and its size. Now actually I'm going to call these f array, just so that they're different than the array names on the outside. And I'm going to copy these and paste them over here in our implementation file, and we're going to change the semicolons to curly braces. And so now we have the ability for our two functions that we're going to make. And so we're going to kind of do similar things in both of these. We're just going to do a for int I equals 0 while I is less than size and I plus plus. And we're just going, for the init array, we're just going to give it values of I. It could be simple. So this is f array sub I is going to equal I. And then for the print, we're going to do something similar. So I'm going to just copy this for loop, and we're going to put that down here in the print. And what we're going to do is, instead of setting the values, right, we're just going to print it out. So cout, and the f array sub, and then we'll put the I. If I could type, it'd help. And then we'll actually put the value of f array sub I, and we want an endl. And I have those variables the using on the previous one, but I don't have on here, so I'll just put a standard cout, standard endl. I don't need the cin because I'm not going to do input on this one, so we'll just do it this way. So this is just initialize my array and then print out what's the value in the arrays. And I'm doing this so that we could show you, right, that how this is working. This is when we dynamically allocated it, or when it's allocated on the stack, right? So we're going to just say init array and give it the array and size. And then we're going to say print array and size. And then what I'm going to do is I want to say cout, please give me a new size. And cin, we're going to update size to be that new size. Now you're going to see, right, and then we're going to do this two steps all over again, where we just print out the values of the array. And you're going to see we have no errors at all right now. We're going to hit compile. We have no errors, right? So this looks like it's working, right? And now we're going to execute it. And so with the 5 items in it, it worked just fine. Now it's saying give me a new size, and I'm going to say 15. And it crashed. And it crashed, right, because that exceeded the size that we had originally created for it, and so it was not happy with that. We run it again, and it says give me a new size, 6. Oh, it printed 6 just fine. So let's try it again, and we do 10. 10, oh, it created 10 just fine, right? So now, how about 12? Oh, look, it still only did 11 this time. It didn't do 12, right? Hit it again. So 13. And now we crashed again. So that's what I'm trying to get at, is like trying to allocate it this way dynamically is not really appropriate. And it's because it's trying to allocate it to the stack, and when you change this, it didn't resize it. So that's the problem that it's having. So what you'd really want to do with this is, how you really want to handle this is like the bad way you're doing it. So the true way you want to do it, so we're gonna just hide this stuff, right? And we're gonna actually we'll just change this one, right? And so we're gonna do int array, and it's gonna be a pointer, so we're gonna say star pointer array, and it's gonna be new, and it's gonna be an int and of size. And so now instead of this one that is allocating it to the stack, this one's going to allocate it to the heap. And so now, right, we're going to still have it be the 5. And so we're going to pass in our p array. And so we're just going to change them all from that to p array. Now, we can't just move on and let this work, right? Because how big is our array right now at this point? It's still, even though we got a bigger size here, we might get a bigger size here, our array is still this size of whatever our initial one was, which is 5. So what we need to do is, and we don't really care about the values in this. If we cared about the values, we might want to temporarily store off the data that is in this array. But before we did this, but what we're going to do is we're going to just delete this, the value, right? And what we're deleting is not the variable p array, but the value that's in p array, which was this that we created. Now we're going to create a new one, which is p array equals new int with our new size. And now this new size means that when we put in, if it's whatever it's going to be, it's going to print out correctly and give us what we need. So we compile it, see that it worked, no problem, and then we're going to execute it. Now when we execute it and we say, 15, we're going to end with no problem. And if we run it again, and this time we put like 100, we run it and it has no problems. And that's because we reallocated it to have the correct size in this. And that's not something you can really do the other way, right? If I try reallocate just this section, right, I can't, because the only way to reinitialize the size is by using int array and the new size. And I can't do that, right? If I just had array and like say 10, what this is doing is telling it get element number 10. It's not saying reinitialize to the size 10. It's saying go get element number 10. So that's kind of why the way we're doing it is doing dynamic allocation is the best way. And it makes it so that, again, we can make a shopping cart that is only 5 to start off with, and then increase it to 10 or increase it to 15 or 100, depending upon the size it needs. So it just lets us to have more variety and more control over how much memory we're allocating for our resources. In the next video, I'll go into a little bit more detail about memory leaks and what they are and why it's important. So I'll see you in the next one.